Okay, problem 3 has this cargo canister, which is a crate or something that was initially stationary but now moves across the frictionless floor. The force magnitude, so these three forces are constant, and they give them blah blah blah. So we want to find the net work done on the canister by the three forces during the first 4 meters of displacement. So the thing to think about here is that we got these three forces acting. They're going to sum up to one net force, which is going to push the canister somewhere. And it starts from rest. So it was initially stationary, but now it's moving because of these forces. So the key thing to remember is that when we find, the net force, wherever it's going. So let's say this is our F net here. Well, this thing starts to rest, which means it's going to start moving in that direction. It's going to move in the direction of the net force acting on it, right? So what we can do the easy version where force and distance traveled or force and displacement vector are in a straight line, are all collinear, and we just say the work done is this net force times d. And when they give us d, they say first 4 meters, right? So all we need to do is find the magnitude of the net force. We don't even need to find the angle, although, anyway. So let's take our forces. Let's see. So F1 was 3 newtons, and that went. So F1 was 3 newtons like that. Okay, F2 is 4 newtons, and it's at a 50-degree angle from vertical, which means it's at 40 from horizontal. Okay, so F2 is 4 newtons, and this here is a 50-degree angle. Okay, and then F3 is at a 35-degree angle from horizontal, and that is 17 newtons. So that's going to be F3 is going to be like that, 17 newtons, and it's at a, what would it say, 30, I better check this to be sure, 35 degree. I don't know what's up with this. Half the time when I try to copy and paste a WebAssign picture, it ends up coming down as black, so, whatever. 35 degrees. 35 degrees, right? Yes. Okay. So let's break these all up to components. So F1 here really is just -3 I hat newtons, right? And then F2 is, it's going to be 4 newtons. Let's see, -4 times sine of 50 degrees I hat. Okay. Plus -4 cosine of 50 degrees j hat, and this is all, I guess you can put newtons on this, okay? And then finally F3 is going to be, so this is just breaking it down to components, F3 is going to be 17 newtons to the right times cosine of 35, that's actually I hat newtons, and then it's going to go up, it's vertical component, so plus 17 sine 35 degrees j hat newtons. So we can take our power calculator, which I really like, and just add all these things up. Shouldn't be very hard. So let's see. Let's do the x direction first. -3 minus 4 times sine 50 plus 17 times cosine 35. And whoops, unknown characters. All right, because I didn't close my parentheses. There we go. Okay, so this is our x component is positive 7.86 newtons. So F net equals 8.76 I hat newtons. And then in the y, we have force 1 has no y component. Force 2 is -4 times cosine, whoops, well, I'll put an answer. -4 times cosine of 50. And then F3 is plus 17 times sine of 35. And that gives us 7.18 newtons plus 7.18 j hat newtons. And so the magnitude of F net, we just apply the Pythagorean theorem to that, right? So to do power toy. All right, square root. So answer squared, which is the previous one squared, plus 7.86 squared gives us a magnitude of 10.64 newtons. So the magnitude of F net is 10.64 newtons. And we know that Fnet, the direction Fnet is acting, is the direction it's going to move because it started from rest. Okay, so work is simply magnitude of Fnet, times d, and d they gave us is 4.0, right? So it's going to equal 10.64 newtons times 4 meters. So let's get that right, times 4, and it's going to be 42.6 Newton meters, let's hope, or joules, 42.6 joules, which is a Newton meter. And ding, 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 got it right. So that's how you do problem 3.